Hello, I'm Kushagra, and this is the demonstration video of my CMP 502 project. To launch the application, simply click the exe file, and it will start at the sunrise scene. Now let's talk about the elements we have. We have a tessellated plane mesh, as we can see in the wireframe. It's dynamically tessellated, and the vertex manipulation is now being done in the domain shader instead of the vertex shader, since we have new vertices to deal with. In our domain shader HLSL file, here are we setting the positions using the getHeight function, which uses the height mapped texture. With dynamic tessellation comes an issue of edge cracking. We solved it using correct edge mapping and edge factor calculation. The terrain can cast and receive shadow, as we see here the shadow of the sphere, the streetlight model, and the house. It casts shadow on itself during sunrise and sunset because the direction of the sunlight is not enough in the y direction. We can see the shadow maps in RenderDoc. This is the shadow map at sunrise. Apart from that, we have a sphere mesh to cast a shadow and to receive lighting. We have the streetlight model, which is an imported model, and we have a cottage, which is again an imported model. We have a sky dome sphere, which is rendered at the camera position with backface culling off and depth buffer off. So it gives us illusion that it is a natural distant skybox. We also have this plane mesh with alpha blending on and cloud textures, which change UV value over time. We have a sphere for sun, which is rendered at the directional light position, and that position changed based on time, and hence we get sunrise, noon, and sunset. Now, if we talk about lights, we have this directional light, which is our sun, which changes its position, direction, and intensity based on time. We can see all of those values in the main window. We have a spotlight, which is fixed at this location for now. You can change it using the debug window, and both of those lights are able to cast shadows, and we can see their shadow maps in RenderDoc. This is the sun as shown earlier, and this is the spotlight shadow map. For post-processing, we have color grading and bloom. The sun and the scene are bloomed separately because the sun bloom should be much greater than the scene bloom, and hence they have different set of shaders. For color grading, we are getting values for brightness, saturation, contrast, and tinting. This is the pixel shader for color grading, and here we are setting the brightness, then contrast, then saturation using luminance formula, and then at the end, tinting. We can turn off post-processing using our UI booleans, and we can see the scene look very dull. And now we come to UI. For UI, we have a main window which shows us data for different elements, time out of 24, and in terms of the variable elapsed time, the light data, the position, color, direction, specular color if there is, and everything else. The player or the camera position and rotation, which changes based on the camera player position and rotation. We have the scene enhancement bools. We can turn off shadows. We can turn off post-processing. We can pause time. We can also reset time to sunrise and then see the whole cycle again. We can go into debug menu and change the properties for the dial lights and for the models. We can also change time scale and make the days go by quicker. We also have a statistics window which shows us FPS and frame time, and we have a wireframe to see the wireframe mesh of our objects. That's a quick overview and description of the project. Thank you for watching.